Now let's look at how we're going to handle multiple users, segregating the data so that one user can't see another user's data. This actually brings up the topic of authentication versus authorization. Authentication is proving who you are, validating who you are, usually with something like a password. Sometimes we have things like two-factor authentication, where you also prove that you're at, say, the other end of a phone number. That helps prove who you are. Now, authorization is the determination of what you're allowed to access. Sometimes this might be an API endpoint. You're allowed to access that API endpoint. And so far, it's pretty much been binary, right? If you're authenticated, we say that you're authorized for that endpoint. But now what happens if I have multiple pieces of data, like, for instance, a diary entry for Jason and a diary entry for Jim? Now I need to make sure that Jason can only get Jason's diary entries and Jim can only get Jim's. So now we have to actually consider this authorization question. Authentication is what we've really been mostly dealing with before this point. And by default, of course, what Azure will do is just say, if you're authenticated, then here's the data. That's all I require is authentication to access this table or this endpoint. We need to change this. Now, remember, our authentication mechanisms give us access to a user ID, something that came from our IDP that uniquely identifies each user. So what we're now going to do is modify our schema so that we have a user ID in our table. Now, of course, we're going to have to actually include that data whenever we create a row. Say this row, this diary entry, for instance, is for this user. And of course, it'll be whatever user happens to be logged in at the time. Now then, when we show data, we'll need to filter it. Now, it might be tempting to simply add that filter right at the client side, say, all right, from this diary table that we synced from the server, let's go ahead and filter the data. However, if we do this at the client side, of course, we've got all the data, the unfiltered data, going over the wire. This really is not what we want. This really is not secure. That means Jim logs in and Jim only sees that data, but if he pulls something up like Fiddler, for instance, he's going to see all the data going over the wire, and he's going to see Jason's diary entries. So we really need to filter our authorized data at the server side. Now, if we're using easy tables, we're going to actually be able to do this by opening up that table.js file that we saw earlier, that table.js file that's part of our easy table source code. And there's actually a function available for each of our operations, each of our CRUD operations. So you see that table.read will get a context in, and this context by default is just the method that will do the reading. So in other words, table.read function will context.execute. It will just execute the read function. However, we have access to some additional properties in the context. Things like the currently logged in user, the current query that's going to be executed, of course the execute function, and a few other interesting little items. So we can use those to modify that table read function. So now I have that context, and I'm going to say context.query.where. Now I'm filtering this. This is on my Node.js file here. Now I'm filtering this and saying that the user ID that I added to that table must match the user ID that's currently authenticated, that passed in the token now. So now everything that goes over the wire is filtered based on who's currently logged in, who's currently sending their token. Same thing, of course, for the insert function, etc. Update and delete will work the same way. Now, of course, if you've already started using offline cache, you will need to modify or purge the data for each of your offline clients because they'll have their own copy of data that may include some other user's data. So maybe call purge, for instance, when logging out or logging in on the client side to make sure that there's no data from another user. Now, Visual Studio Mobile Center has this Node.js per user stuff built right in. When you create the table, you just click a checkbox and it will create the columns and it will do that login filtering for you if you've added this per user data check. It does exactly what we just talked about. It just does it for you when you're going through Visual Studio Mobile Center. What if you're using an ASP.NET endpoint? Well, in that case, you will have to find your user ID again. And in ASP.NET, your current user is usually available as a claims principal. So you're going to get your current user as claims principal, cast that. Then you will go through its claims and find the one called name identifier. You can then use that as your user ID in order to do your filtering. And you can see that in your table controller, get all, for instance, your query is wearable. So you'll add the where clause there, do your filtering, and now once again, everything that goes over the wire will be what's supposed to go over the wire, the data that's filtered to the currently logged in user. And now we'll look at a version of our solution that's been modified so that when I'm authenticated, we're only going to see my diary entries. When you're authenticated, we're only going to see your diary entries. And the changes that we have here on our mobile project are actually very, very simple and lightweight. Firstly, we're just pointing at a different table. We're not pointing at diary entry 3. On the server side, diary entry 3 is a table that has user ID records. And of course, we've now changed our model to support user ID records. The last, most important change is also on the server side, though. That's going to be where it's filtering all of the calls based on the credentials that we send. We're already sending the credentials every single time we make an API call to identify ourselves, and now the server is filtering that.